evaluate by Green's theorem this line integral where C is a rectangle with these given vertices. So let's plot these vertices first. Let this be the origin and this be the point pi 0 and this is the point pi and pi by 2 and this is 0 pi by 2. Let me join these points. Let's name them the origin O and this the point A, this the point B and this is the point C. Now let's take the region enclosed by the curve C. Alright, let R be the region enclosed by the curve C and let's consider this to be P and this to be Q. Now both these functions are continuously differentiable functions, right? We are having the trigonometric functions and also the exponential functions. So these are the continuously differentiable functions. Their derivative exists and also these are continuous. So writing this, since e the power minus x sine y and e the power minus x cos y, these are continuously differentiable functions. So now we can apply the Green's theorem. So therefore, by Green's theorem, the given line integral is equal to the double integration over the region R. Okay, if this is P and this is Q, writing here first partial derivative of Q with respect to x, yes, minus partial derivative of P with respect to y. And writing here dx dy. So this is equal to the double integration over R. Okay, let's derivate this with respect to x. So this is e the power minus x with negative sign cos of y minus, okay, derivating this with respect to y. So this is e the power minus x and the derivation for sine y is cos y and writing here dx dy. So this becomes minus twice e the power minus x cos of y. So this is minus twice, I'm taking minus 2 outside of the integrals, the double integration of e the power minus x cos of y and writing here dx dy. Writing the limits for x, it is from 0 to pi. So this is from 0 to pi. And writing the limits for y, it is from 0 to pi by 2. Very fine. Okay, let's integrate this with respect to x first. So we get minus 2, the integration from 0 to pi by 2. And the integration of e the power minus x will be e the power minus x divided by minus 1. So this is e the power minus x divided by negative 1 into cos of y with limits from 0 to pi, and here I am writing dy. Managing these two signs, that becomes positive from 0 to pi by 2 e the power minus x cos of y with limits from 0 to pi dy. So this is twice the integration from 0 to pi by 2. Okay, putting the upper limit for x, it is e the power minus pi cos of y minus putting the lower limit on x, it is e the power 0, that is 1. So I'm writing here cos of y only dy. We can take cos common from here and we get e the power minus pi minus 1 into cos of y, right? And now taking this constant outside of this integral, so this is twice of e the power minus pi minus 1 and the integration from 0 to pi by 2 cos of y dy. So this is twice of e the power minus pi minus 1 and the integration of cos y is minus sin y with limits from 0 to pi by 2. So this is equal to twice e the power minus pi minus 1 and putting the upper limit for y, it is sin pi by 2, that is 1. minus putting the lower limit, it will be 0, sine 0 is 0. So we are getting our answer to be twice of e the power minus pi minus 1. This is the required solution for the given integral. So by Green's theorem, we have found the answer to this integral to be twice of e the power minus pi minus 1. Okay, thank you. Stay blessed.